All right, we're on. Today's lesson is 8.3. We're going to look at the laws of logarithms, log laws. In grade 9, when you first learned how exponents worked, you learned the power laws and the power rules. Well, logarithms are basically just the inverse of exponentiation. So they also have their own rules. And just like the first one in powers and is called the product law, you can usually call this one the product of log laws. Product. And please notice that when I say log to the base a of something, unless I see a plus or minus in here, I assume all of this is the argument. I don't need to put those brackets there, but I know they're there. I assume that they're there. And the product law says that log to the base a of a product is the same as log to the base a of m plus log to the base a of n. In other words, you can split the product into an addition, into a sum. So for example, log to the base 2 of 6 could be thought of as log to the base 2 of 3 times 2, which is the same as saying log to the base 2 of 3 plus log to the base 2 of 2. And you might be thinking, well, this is kind of easier looking than that because this is just 1 log and this is 2. Yeah, but keep in mind, I know this one just mentally. Log to the base 2 of 2 is like asking the question, hey, if I multiplied together 2's, how many steps would it take to get to 2? So that's the same as saying log to the base, log to the base 2 of 3 plus 1. So there we go. Example 2, or law 2, is called, as you could probably tell, the quotient law. I don't care if you remember these names. So first one's the product law, second one's the quotient law. Notice it works very similar to the way that exponent quotient law works. If I'm taking the log to the base a of a quotient, the argument is a quotient, I can split that into 2 separate arguments where it's the numerator's argument minus the log of the denominator's argument. So for example, I could say log to the base x of, oh, wait a minute. It's already written down for me. I'm writing down the example like it's not there. Sorry, it's right here. Log to the base x of 8/3 is the same as saying log to the base x of 8 minus log to the base x of 3. All right, third log law is the power law. And it says that log to the base a of a power with a base of m and an exponent of x is the same thing as saying x times the log of a to the power of m. In other words, exponents, when you are in logarithm notation, exponents become coefficients. So that allows me to simplify something like this. I can say that this is like saying log to the base 3 of 6 to the 1/2, because that's what the square root means. And then, since this is basically like this x here, I can say that that's 1/2 times log to the base 3 of 6. Finally, we hit one that I kind of promised you last week we'd be doing. Right? If you are looking at something like, well, like for example, I want to figure out what log, from this first example, what log to the base 2 of 3 is. I mean, we can estimate it, right? So here, let's just say log to the base 2 of 3. Well, I know that if I'm counting by multiplying 2's, 2 to the 1 is 2, and 2 to the 2 is 4. So it's somewhere between 1 and 2. Maybe 1.5, something like that. I'm estimating. How do you find it exactly, or at least to several decimal places? You'd use what's called the change of base rule, or law. And the change of base law says that, for example, if If I have log to the base a of x, that's like saying log of x divided by log of a. And remember, when I don't put a base here, remember that I'll say recall log x means log to the base 10 of x, right? You don't have to write the 10, you know that it's there. So, for example, if I had log to the base 2 of 7, I could say that that's the log of 7 divided by the log of 2. And that means, let's get the fancy calculator out, that now I can use my calculator and find a reasonable decimal for this. 2, again, 2 to the power of 3 is 8, 2 to the power of 2 is 4, right? So it's somewhere between 2 and 3. 2 point something. I'm thinking closer to the 3 because 7's closer to 8. But let's not guesstimate. Let's calculate. Clear, clear, clear. Log of 7. Now careful, if you have the kind of calculator like mine, notice it opened a bracket for you. Close that bracket again because you're moving on to divide. Log of 2, close bracket. Everyone should try this in their calculator. Boom, you get that. I was right, it was closer to 3. What was it again? 2.80735, 2.80735, yada, yada, yada. Isn't that nice? So we could actually answer the question we had a second ago. What's log to the base 2 of 3? So log to the base 2 of 3 is like saying the log of 3 divided by the log of 2. So let's see if we can figure out what that is. Let's see. Log of 3 divided by log of 2. And what did I think it was? It's 1 point something. I thought 1.5. Pretty close. 1.5849. And you know you can actually check these answers too. Like for example, if I think that log to the base 2 of 3 is 1.5849, actually let's go back to this example since it's already in your book. I kind of just made that one up. There we go. Let's go to this example. So let me punch the number again. So it was, let me move that over a bit. It was log to the 7 divided by log to the 2. So log to the 7, close bracket, divided by log to the 2 equals. And okay, so there we go. That's the answer. My calculator knows that answer, right? So remember that, I'm going to move this over a bit. Remember that log to the base 2 of 7 can be rewritten in exponential form, right? So again, recall that log to the base 2 of 7, if I say that that equals some number called like x, if I rewrite that in exponential form, that means that 2 to the power of x is 7. And there's that problem, right? 2 times itself, how many times is 7? Well, I don't know. Again, 2 squared is 4, 2 cubed is 8. It's somewhere between 2 and 3. We found out that it's actually that number exactly. Let's prove it. Take your calculator and go 2 to the power of, and if you have an answer button, mine's a shift to get to it, but can you see it right there? Second function, and it's on the negative sign for some reason. And look at that. Exactly 7. So every time algebraically you've ever been stuck trying to figure out how do I solve for the x when it's the variable is an exponent? Well, now you know. You can just use your log button thanks to the change of base rule. And the change of base rule, if you want to think about it, if you have, say for example, I'll go back to this one. So I have log to the base 2 of 3 equals x. So that means that 2 to the power of x is equal to 3. And you can do something to this equation. You can take the logarithm of both sides, and by logarithm I mean to the base of 10. And if you take the log of both sides of the equation, and then you say, well, yeah, but one of my log laws back here, log law number 3, was that an exponent is really a coefficient. So go back over here, and I can say that this exponent is a coefficient. And now you can see where I'm coming from. Divide both sides of the equation by log of 2, and that's where the change of base law comes from. It comes from just using logarithms algebraically. So you can just remember it as a rule if you like, or you can just see that that's how the algebra works. So the log button on a calculator is of base 10, therefore it is this button can only be used to find solutions to questions with a base of 10. There are, of course, fancier calculators that have logarithms where you can enter in any base you like. I don't have one of those in front of me. This thing, of course, is a TI-83. Oops, hey, come back. TI-84s definitely have a log button. Yeah, I don't have a fancy enough calculator in front of me. Oh, wait, well, I do have a TI-84, but does it have... TI-84 Plus. Actually, you know what? Now that I think about it, it has to be a TI-84 Plus. So, yeah, if you have one of these kind of fancier calculators, let's see, let me close out of here, and let me go back to here, and let me stop sharing for a second. Stop sharing screen. Right, now I'm nice and big on the screen, right? You can probably see me. Oh, did my camera just freeze? I think my camera just froze, didn't it? Oh, there we go, I'm back. Okay, so on this thing here, if you go on, can you see that? And if you take your math button, which is this button right here, if you have one of these calculators that has a math feature, go to math, and then under math, I scroll over to, I believe it's number. So under number, and then I hit enter. Oh, no, that's not it. Hang on. Math, number. Oh, there we go, under number, and then I scroll down. On number, I scroll down. It's near the bottom someplace. No, it's not. Is it under math? Maybe it's under math. It's not under number. Yeah, there it is. Okay, took me a while to find it. Sorry. I haven't used this calculator in a while. So, starting over. When you're looking at your calculator, hit the math button, and then up will come an actual list of things for math, and go down on that list, down, 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 until you get to log base. Select that by hitting equals, and look at that. Can you see that? I hope you can see that. That allows you to put in whatever base you want. So you could do the one that we just did, log to the base 2 of 7. So put in a 2, and then toggle over, put in a 7, and then hit equals. And there you go, it calculates it for you. So since I don't have that feature on most of my calculating devices, let me go back to sharing my screen here. There we go. You're all looking at my screen again, I hope. There we go. Okay. Since I don't have access to that, I have to type it in as log 7 divided by log 2, but it gives me the same answer. Okay, so that's the change of base law, and that's it for the log laws. No, notice, oh, there's more. For example, this can't be put into most calculators, so yeah, I just showed you that. Okay, so log to the base 2 of 7 is, what was my number again? It was 2.8, what was it, 0735. It's an irrational number, so whatever. And of course, that's how you calculate it. All right.
Mr. Cullo?
Yes?
Do you possibly have a Casio calculator?
I've got one in front of me, but it may not be as fancy as yours. If you've got
because mine has it.
Yeah, you've got one of those fancy Casios. Yeah, yeah, good for you. We will, of course, have some questions that allow you to use a calculator, and some that it's basically just algebra. Like notice example 1 here doesn't really have any numbers, and it says, well, it has a 2 and a 1/3, but for the most part it's variables. So you actually have to use the log laws with variables and stuff. So on calculations where you're working with numbers where you're allowed a calculator, you can use that button if you like. Yeah, I have an older Casio. I don't know if you can see that, but this one doesn't have the fancy log. But if you have one of those really nice Casios, it has it. TI-84 Pluses have it. There's a Sharp. There's a very expensive Sharp one, like a $50, $60 calculator that has it. Most calculators don't. Okay, anyway, let's do some examples with some algebra. So simplify this expression. So we're going to use our log laws. Okay, so first of all, I'm going to use law 3 backwards. Right? This coefficient can be written as an exponent. So there's my first thing I'm going to change. And this coefficient can be written as an exponent. So there's my first step. Now, you know what? For my second step, I think I'll get rid of the bracket. I'll distribute that minus. There we go. And now I'm going to rearrange. I'm going to put the two things that I'm adding together. You know what? I'm going to do one other thing too. I'll do two steps at once here. Did everybody get what I did? Right? Power of a third is like saying third root. Now I'm going to use my product and quotient rules and say that this is equal to the log of x squared cube root of z all over y. Right? Adding is like multiplying, and subtracting is dividing. And there. To a mathematician, that's simpler because it's only one log, not an expression involving 3. But anything you can do forwards in math, you should be able to do backwards. Let's fully expand this simplified log. Okay, so multiplies can become adds, and exponents become coefficients. And of course, I'm dividing by these two, so that's a minus. There, fully expanded. Take a second and think about how I did that. So there's just some algebra. We'll definitely have some questions like that for you to practice. Guarantee you one or two of those on the test. Then we'll get to some numbers. Simplify and evaluate the following expressions using the laws of logarithms. And for these two for sure, no calculators. Sorry with your fancy Casio there and my TI-84 Plus. No calculators. And you're probably going, like I know how many times I times 6 together to get 8. It's obviously 1 point something. How am I supposed to know that without a calculator? Well, check it out. This is a plus and this is a minus. So this is like saying log to the base 6 of 8 plus 9 divided by 2. Sorry, plus. Sorry, that's a typo. Times, thank you, it's product law. It's 8 times 9 divided by 2, which is like saying log to the base 6 of 72 over 2, which is log to the base 6 of 36. And you should not need a calculator for that because you can either just look at it and just know that, oh yeah, 6 times itself twice makes 36. Or if you have a hard time kind of thinking about that, at this point you can call that x and then rewrite this in exponential form. Base, exponent, argument. And right there, 6 times itself how many times is 36? The answer is 2. If you don't need this part here, I'm perfectly happy if at this step you just say log to the base 6 of 36 equals 2. You don't have to reintroduce algebra to it if you don't want to. And you don't have to switch to an exponential equation if it totally makes sense to you that, oh yeah, log to the base 6 of 36 is 2. Alternate strategy, if you're looking at this, you can, of course, recognize that log to the base x of x is always 1. So 36 is 6 squared, and we just learned a rule that exponents become coefficients. And if this is 1, that's 2 times 1. Oops. Guess I should close. Oops, hang on. Guess I should close this thing before it keeps coming back to haunt me. There, go away. Anyway, like I said, log to the base 6 of 6, logs to the base x of itself is always 1, so this is just 2 times 1, which is 2. Okay, so there's several ways you can think about this. Whichever one makes the most sense to you, you kind of go with. Now, they get more complicated. Check out B. All right, so I'm going to switch this coefficient to become an exponent. So that's 12 squared. And when I'm minusing, that's like I'm dividing. And when I'm adding, oh, wait a minute. Sorry, what am I doing? I don't know. Dividing. There we go. So when I'm subtracting, it's like dividing. And the goal here is to make this all one log, one argument, I should say. And the adds, of course, become multiplies. So this becomes a 6 times, and then again, this coefficient can become a power, but 27 to the 1/3, you should recognize 27 to the 1/3 is the cube root of 27. So there we go. There. Now it's all one log, and I think I can play with this without my calculator. I do know 12 squared is 144, or, oh, I got a better idea. I'm going to leave that right now. And I'm going to take 6 times, the cube root of 27 is 3. And then I'm going to think of the 12 squared here as 12 times 12 to make my life easier, and 6 times 3, and then of course, how about this 6 goes into this 12 twice, this 3 goes into this 12 4 times, and I am looking at log to the base 2 of 8. And again, now we're at that spot where you can switch this to an exponential equation if you want. You can say this equals x, so 2 to the power of x is 8, and then from there realize, oh yeah, it's 3. Or you can just count it. You can say it's how many 2's do I multiply together to get to 8? The answer is 3. Or, again, alternate strategy, if you're looking at this, you can say that that's log to the base 2 of 2 cubed, and this 3 becomes the coefficient, and then 3 times 1 makes 3. So there we go. There's numerics that you have to deal with using your log laws and your number sense and your knowledge of exponents. And this is really old school. In the days before we had calculators that could calculate this stuff for us, we used to look this stuff up on tables, and we would look up tables based on, for example, what the log of smaller numbers was. Like, so for example, I might not on my table actually have a list that tells me what the log of 150 is, but I know that the log of 2 is this, the log of 3 is that, and the log of 5 is that. So I'm going to try to express 150 in terms of 2, 3, and 5, which is not that hard, because 150 happens to be 2 times 3 times 25, or 5 squared. So now, using my log laws, I can change this from a product to a sum. And this exponent becomes a coefficient. So I know that the log to the base a of 2 is 0.3. The log to the base a of 3 is 0.48. And the log to the base a of 5 is 0.7, but I have 2 of them. And I can just say then that that's 0.3 plus 0.48 plus 1.4. So I could just maybe do that in a column, 1.4, 0.48, and 0.3. So the 8 by itself, 4 and 4 is 8, and 3 is 1, carry the 1. 2.18 is my final answer. And notice there's no calculator to do that one because I don't even know what the base of A is. All right, let's try a similar one here. So log to the base A of the square root of 10/3, which is like saying log to the base A of 10/3 to the 1/2. And that's like saying 1/2 times log to the base A of 10/3. And that's like saying 1/2 times log to the base A of 10 plus log to the base A of 3. And that, I don't know anything about 10, but I know 5 times 2. So that's like saying 1/2 times log to the base A of 5 times 2 plus log to the base A of 3. And finally, expand one more time. And that's log to the base A of 5 plus log to the base A of 2 plus log to the base A of 3. And that will be 1/2 times, what were my decimals again? 0.7, 0.3, and 0.48, right? Oh, wait a minute, I made a mistake. Oh, do you see my mistake? Divide is a subtract, not an add. So that should be a subtract. And that should be a subtract. There we go, fix that for me, would you? Okay, so that's 1/2 times log to the base A of 5 was 0.7. So that's 0.7. The log to the base A of 2 is 0.3. And log to the base A of 3 was, oh, that's a subtract. Again, I want to get rid of, for some reason I don't like subtraction today. Eesh. Log to the base A of 3 was 0.48. Okay, so this is 0.7 plus 0.3, which is 1. 1 minus 0.48 is 0.52. So I have 1/2 times 0.52. Quick, what's 1/2 of 52? 26. And there we go. We do not allow calculators for questions like this. This one, however, I think we might need, I don't know, we might need a calculator for this guy. Log to the base A of 3 is 0.48. Find the value of A. Yeah, this one I'm going to need a calculator for. So all of the questions in the examples up till now would have been on the part of the test where we don't let you have a calculator. This one you'd need a calculator. This one you are going to have to say, okay, I don't know anything about what A is as a base, so I'm just going to write that as some A to the power of 0.48 is equal to 3, right? I'm going to change this to base exponent argument. So I'm changing it to exponential form. Then I'm going to say, okay, well, think of course, what we know here, right? We know that, for example, we know that, for example, you know, the square root of, if you have x squared equals 16, of course you know that you're going to square root both sides, right? To solve that, you're going to square root both sides, and you're going to get then that x is equal to plus or minus 4. And in this case, we're dealing with logarithms, so there's not going to be negative arguments, so we can just ignore the negative. Now, think about what you really did here in terms of an exponent. When you square root both sides, well, square rooting, this step here, x squared square rooted, is the same as saying x squared to the 1/2. It's like I took both sides of the equation to the power of 1/2. So that's going to be my logic here. I'm going to take both sides of this equation, and instead of taking both sides to the power of 1/2, I'm going to take both sides to the power of 1 over 0.48. Because on the left-hand side, those two things multiply to make 1 the same way that 2 times 1/2 is 1. And so you get x to the 1. So in this case, I'm going to get A, and then I'm going to use my calculator, and I'm actually going to calculate what 3 to the power of 1 over 0.48 is. So I'm going to go to my calculator, and I'm going to say, okay, calculator, let's move you over a bit. 3 to the power, on this calculator, power is this weird hat. Most of you, it's an x to the y or a y to the x. And then open a bracket so that you get this entire thing and go 1 divided by 0.48, close your bracket and hit equals, and there it is, 9.86. And I don't know, we'll put 3 decimals on it, 9.863. And there we have it. And if we did this right, we should be able to check this. If we did this right, this number to the power of 0.48 should be 3. So let's say we'll take this answer and we'll say to the power of 0.48, and you'd better be a 3. Yay, we did it right. All right, so that's the 8.3 lesson. You can now try the 8.3 worksheet, and if you want extra practice, there is of course always some textbook questions you can do as extra practice. All right, I'll shut off my video.